Hello, scholars. So today I'm going to talk to you for a moment about research questions and hypothesis writing. Now, there's many ways to do it. I'm going to teach you what I like to see. Okay. So when you write a quantitative research question and hypotheses, I always write the question first and then turn the hypotheses into positive and negative statements from the research question. Now, usually we just have two hypotheses with each research question. It's the alternative, there's something going on here, and the null, there's nothing going on here. Okay. The null hypothesis is always stated first. And whenever you test a hypothesis, whether it's for normal distribution, homogeneity of variances, group differences, whatever it is, you should know what the null hypothesis states. Always look. Okay. Now, it is possible to have more than just two hypotheses with each research question. Sometimes there's sub-hypotheses if there's more than one potential outcome. Okay. Or if you have multiple variables put together that could interact in multiple different ways. So I just typically teach this basic method first so that you have a solid understanding. Okay, so I'm going to cover the different types of research questions that you're likely to encounter in your statistics class and for a dissertation in social sciences. There are far more. These are just the basics. Okay, so if I want to know if there's a loose association, this is usually some sort of chi-square test where I've got two categorical variables, grouping variables, and it's a frequency table, right? And I'm looking to see if maybe in this case, is there a statistically significant association? Notice this phrase, statistically significant. That's literally what I'm looking for, a statistical significance in the p-value, right? The probabilities value. And this association right here indicates the type, family of statistical tests that I might be using. So I always start my research questions off with something that indicates the family of tests that I'm going to be using or what I'm testing for. So is there a statistically significant association between, because a chi-square is testing between categorical variables. So this word here is really important. And then I have my categorical variable here with the categories. Notice I put the categories in parentheses. This is not a requirement, but it is a wise idea, and I'll tell you why. As a statistician, I am frequently hired to help people with their statistics or brought on board to help with research publications or whatever. The first thing I'm going to look at is your problem, purpose statement, and research questions. And if you have this information in here right now, it makes my life easier. Okay? So is there a statistically significant association between gender, male versus female? Those are my categories, my groups, and race. And my groups, my categories are white, black, and Latino. For high school students playing sports after school in Ohio. So I've got my high school, my population, high school students playing sports after school, and a geographic location, Ohio. Okay. Research questions, especially quantitative, should be pretty specific. All right. And the first thing I give is my null hypothesis, denoted by H0, subscript 0. Notice that. And it's a negative statement of the research question. There is not a statistically significant association between gender. Here's my categorical variable. And I've got male and female for my categories there. And race, my other categorical variable, right? With its categories, and there are three: white, Black, and Latino, for high school students playing sports after school in Ohio. And if you want to know what this looks like in statistical language, this is the formula. You don't have to use this. I don't require it in my papers. Some professors do. Sometimes it's just nice to know. So it means the probability of A is recurring regardless of the probability of B. So the variables are independent of each other. Okay, that's the null hypothesis. Now here's the alternative. This is what I'm looking for. There is a statistically significant association between gender, my categorical variable, male versus female. Those are the categories of my first categorical variable, and race, another categorical variable, with three groups: Black, white, and Latino, for high school students playing sports after school in Ohio. So the null says there is not. The alternative says there is. And look at my hypothesis if I wrote it in statistical language. The probability of A changes depending on B. See that not equal sign? So this means the variables are associated. Again, I don't require the statistical hypothesis in statistical language. I just require in my papers you're writing these out correctly. Now I put for all of you a template in case you wanted to use the way I write research questions. So here it is. For chi-square or association, it starts off this way. Is there a statistically significant relationship between, because I have to have two categorical variables for this type of test. Here's categorical variable with groups in parentheses, right? And categorical variable with groups in parentheses, right? For, here's my population and my geographic location. So you can fill out what's in parentheses or underlined and then tweak it so that it makes some sense. All right, for a group differences example, right, this is a testing family. I'm using between two groups, so it's an independent samples t-test, two-tailed. All right, there's more than one way for group differences, but all of the research questions would be similar. But this has one independent variable, and there's two groups of the independent variable: a dependent variable, which is numeric, and the intervention, because most of the time group differences are looking for differences between groups. There's not always an intervention. Mine has one. Okay. Is there a statistically significant difference? Because I'm testing for differences between groups. There's within groups tests. So between two groups in participation, and my two groups are treatment versus control. After a treatment group of elementary school students participated in a bullying intervention. So there's the intervention in the number of students who bullied, my dependent variable. And the null is there is not a statistically significant difference. And the alternative is there is a statistically significant difference. And I wrote this out, A equals B. That's the null. The groups are equal. The alternative is the groups are not equal. Now, when you decide after testing which hypothesis you're going with, there's specific language. Okay. The specific language for your hypothesis testing is always reject the null, in favor of the alternative, or fail to reject the null hypothesis. Okay, and this is important. We never say accept. A hypothesis because we deal in probabilities. I covered this in another video, but I will mark you wrong if you say accept a hypothesis. It's reject the null in favor of the alternative, which means there's something going on, or fail to reject the null, which is basically the negative result, meaning there's nothing going on here. Okay, that's a big deal. All right. Now, there is a type of, and I have my template here for group differences, but there's a group differences within groups. So I'm not asking if there's a difference between treatment and control. Maybe I just want to know if one group had a difference over time. So the testing conditions changed for some reason. It could be just due to age, like a longitudinal study. Year after year, I follow a child as they go through school. The testing conditions are aging and growing. My example is just going to be pre-test to post-test. That's the easiest one to understand. So my independent variable is time. And it has two categories, pre-test and post-test. You can have more than just two categories of time. And my dependent variable here is test scores. And this one does have an intervention. Okay. Is there a statistically significant difference over time, pre-test to post-test, in test scores after Ohio fourth graders participated in a new math program? There is not, and there is. Okay. And we can mark these. This should be yellow. So you can see my categorical variable. And you can see my dependent variable here, test scores. And there's my location and stuff, right? Okay. I'm just going to briefly cover the other testing types. Oh, and by the way, I have one-tailed test examples here. It is possible to look just one direction instead of both ways. Instead of just looking for increase and decrease, I can look just one way. So here's a one-tailed example right here. Is there a statistically significant decrease in the number of students who bullied in the treatment group of elementary school students following a bullying intervention compared to a control group? Now notice my template doesn't exactly fit, but it's close, right? It makes sense. Same thing here with my over time, my one-tailed example. Is there a statistically significant increase in test scores from pre-test to post-test after Ohio fourth graders participated in a new math program? Okay. And then the last test we're going to cover today is relationship testing. These are associative correlational tests, not predictive. Okay, this is Pearson R-type tests. It's two-tailed. Again, we're looking both ways for a positive relationship and a negative relationship. It uses two variables, and we simply call them variables here because should both be numeric. There are exceptions to that rule. Is there a statistically significant relationship? That's my testing type. Between mathematical aptitude and emotional intelligence for public high school students from the state of Ohio. There is not a statistically significant relationship. There is a statistically significant relationship. And I have a template here. Okay. And then I have a one-tailed example. Is there a statistically significant positive relationship between mathematical aptitude and emotional intelligence for public high school students from the state of Ohio? And by positive relationship, I mean as emotional intelligence increases, mathematical aptitude also increases, or not. Okay. All right. So if you have any questions, reach out to me. Thank you so much.